Many of you on social media probably saw people posting about Dungeon 23, but today let's try a little bit of Galaxy 24. Thank you all for joining us again here today on Hudson County for a new series. This is going to be entitled Galaxy 24, and the basic concept is that we are going to be this is a play on the original sort of hashtag Dungeon 23 that was running around on social media a lot last year. In that concept, basically, you added a new room to your dungeon every week. Here, instead, what we're going to be doing here on our channel is we are going to be creating a new star system that will be included in a star cluster. This is a basic concept that I had originally created for Urcat, my original games of Urcat and Bannership of the 10,000 Stars, where basically the story takes place inside of a relatively isolated star cluster between three different other major powers that are sort of, attempting to influence or attack or otherwise gain power over this particular star cluster, which is attempting to maintain its independence. So we are going to be creating some of the star systems that will populate that on the stream here. And one of the reasons why I wanted to do this on the channel is that it would allow me to utilize, basically feature a different star system creation system every month. So yeah, that's the basic idea, is that we're going to be making one of these videos every month, which means we should have 12 systems by the time we're done. Although, of course, I might do a couple extras. And the idea is that we're going to be using a different star system generation system for each video. So to start that off, for our first one, that way, we are going to be using this little thing that I found on the internet called Liber Astarte. This is a detailed star system and planetary creation guide. This is an unofficial supplement, so that for Dark Heresy, Rogue Trader, Death Watch, basically Warhammer 40k RPGs. I am not entirely sure who originally created this or what the who officially owns this in any capacity. I'm not going to be, unlike usual, I'm not going to be posting any links down in the description below. We're just going to use it. If you want to find it, you can do a Google search, and I'm sure it'll pop up like in the first 10 or 20. Sure, something will pop up in the first 10 or 20 things. But so far, I've not been able to find like a official website or a posting, and it's obviously not for sale on Drive-Thru RPG or anything like that. But anyway, this I have here on the side. This is basically like an Excel sheet that is a recreation of this star system's data sheet. So we can see I included all of these elements here. This is over here. This is just a chart, so you can see and probably draw some little pictures and stuff. And then down here, it'll list like the actual planets. So the number, satellites, things like that, size, class, so on and so forth, in the orbit. And then, of course, down here, you could actually fill out the specifics of the planetary data sheet. So what I'm going to be doing today is I am not necessarily going to be building out any of the planets with this. I'm assuming we're probably not going to have time for that. Instead, what I'm primarily going to be focusing on is the actual creation of the star system itself. So that will just be like the first couple pages here. If we've got time, maybe I'll build out some more of the system, or I might share that through posts either on my website or through Substack. So we'll see. So here on our very first page of the way this system generation works, it's basically just explaining, that there's a bunch of things that are unique from one star from another. But the two main things that we need to kind of figure out for this is the spectra class and the luminosity of our star. So here it's explaining some of the basics of this. For those of you who are not aware, We generally categorize stars based on their temperature, and usually that's references like a color. And then, of course, for luminosity, for luminosity, basically these are different classes of stars where we're sorting it out based. Oftentimes, the luminosity of the star is impacted pretty significantly by its size. Because of course, if you're looking at an object in space that's really big, if you're looking at two objects that are the same temperature in space, and one is big and one is small, obviously the big one's going to look brighter if they're from the same distance and stuff. So we have all of these classes here. So it goes and explains some of that, and then of course it says here are the specific steps of what we're going to be doing. So the first thing we're going to do is we're going to determine the system type. Which means basically, is this a solitary star system, or is this a star system where we have multiple stars in it? And I rolled a 7, which means this is going to be a multiple star system. So for simplicity's sake, we'll just say that this is a binary star system, which means our star is only going to have one companion. So the next thing we need to go ahead and do is determine the class, the star class and size of both our primary star and also the companion. So what I will go ahead and do is I will need to roll 2d10 twice. The first time determining the sort of temperature of the primary star. So for our first one, I rolled a 9. So that means this is a G-class star, which means it is of a similar type as it's of a similar, like, basically temperature as ours. And then let's see, 9 is, and then this one is a size 5, so that is basically a main sequence dwarf, a main sequence star. So basically GV, this is going to be very similar to Earth, to our sun, right? Then I need to roll decimal classification. So basically, whenever you're talking about stars, then you'll have basically a rating between 0 and 9 that determines the rough temperature of the planet inside of that scale of the range. So for example, if we look here, type G stars are ranging between about 5,000 and 6,000 degrees Kelvin, and have an average mass that's slightly larger than the sun, 1.1 solar masses. So again, if we look here, if we're depending upon what we roll here, this could be the same class but a bit warmer or a bit cooler than the Earth's sun. And I rolled a 2, so this would be a 2G 2G main sequence dwarf. And then of course we need to go ahead and do the same for our companion. So for that, I rolled an M, so class M3. And then for that one, I rolled a... Okay, so we have another main sequence star. So we have 2 main sequence stars. Both of them are not super bright or hot, so that's good. Then the next thing we need to do is we need to determine like how closely these 2 stars kind of orbit with one another. This is something actually that I just realized the table doesn't actually note. So basically, if we look here, the orbits down here where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blah, 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 all the way out, way over that way would be on notch 19 would be the companion star. So it says here to determine the number of orbits, we need to roll a d10. Then it says here for large mass stars, basically we could potentially add lots of orbits. For M's and K's, we would have less because, of course, if the star is of a smaller size, but those intensities, then that means its mass is probably smaller and therefore will have a weaker gravity. Hence why, for example, if you take a look down here at this red dwarf, there's only 5 orbits there, right? So I'll go ahead and roll that d10. This is for the primary star. There's not going to be any modifier to this, so the max we can have is 10. And I rolled an 8. So the max number of orbits that we can have here is 8. So we can't have anything over there, so I went ahead and blanked those out. And then we'll go ahead and roll for our other one. Again, we have a d10. We're going to subtract 6. I rolled a 7, so this one only can have 1. So there we go. That should handle that. Now, it also says here there's an optional rule for if we have multiple orbits in this multiple star system like this. Basically, if our stars are too close together, then there isn't room for planets in between. In this particular case, we mentioned that our companion orbit was at 19. Basically, our secondary planet would be far out, our secondary star would be far out beyond the Oort cloud, so we don't really need to worry about, or not far outside the Oort cloud, but beyond the Kepler belt and things like that. So we don't need to worry about extreme amounts of interference in the actual inner solar system around our primary star. So yes. Now here we have a section where they're talking about stellar orbital zones. So here they give us a series of charts based on the sizes. So red would be something that's actually inside of the atmosphere of the star. That sort of corona section of the star, and so obviously nothing can survive there. Orange is basically temperature so high that any sort of planet forming there would have been vaporized. We have yellow, which is the inner zone. So in other words, this would be like the area where like Mercury is in our solar system. The habitable biozone is this sort of teal color, and then the outer zone is blue. So we're going to go ahead and take a look at here. They have them sorted out by type and then luminosity running down the side. And both of these are main sequence stars. So we're going to pop right here. So for our first one, I guess you could say that this one at least has the possibility of being a habitable system. And then for our primary star, this is a G2. So G2, that would be somewhere in between here and here. We'll just go with this one because it's closest. So let's see. The first 2 orbits would be yellow. The second 2 orbits are blue. And then, yeah, everything else would just be like the dark blue. So these are, actually no, I'll make these blue. And then actually I'll make these green just to make them easier to see. All right, now here it says determine the contents. So basically what we're going to do is we're going to roll here using a D100 in the inner zone, which would be here, the habitable zone, which would be here, and then the outer zone, which would be out there. And then we need to determine basically what is in that system. If it are in that orbit, if it's empty, if there's an asteroid belt, if there's a planet, so on and so forth. So here we go. For our companion first, actually. So this is rolling on the habitable zone table, and I rolled an 86, which would be here. It's glaciated. So there is a planet, but it's an ice ball, which makes sense because it's orbiting a relatively weak star and it's pretty far out from the rest of the solar system. So the others far enough away from the primary star that it's probably not getting that much radiation, at least on a regular basis. So I'm going to go ahead and roll the 2 orbits here for the inner system for our primary planet. Okay, for the first one I rolled a 78, which would be a reducing planet. Which, let me see if it describes these. Yeah, so if we look here, it says a terrestrial reducing planet. Basically, this is a world not capable of supporting common forms of life as we know it. So there might be an atmosphere of fluorine, chlorine, or other super reactive gases or acids make up the hydrosphere. So essentially, it has an atmosphere, it has all that stuff, but it's incredibly hostile. The next one I rolled was a 70. Again, we're in the inner solar system, so here we have a super terrestrial. So this is like a super Earth. So it doesn't actually, in the description in the back, it doesn't actually describe what a super terrestrial is, but my basic assumption is just that this is essentially a super Earth. So it also likely has an atmosphere. However, my guess is that it's probably not that habitable, it's probably more like a desert planet, or just generally hostile to life, just because of temperature and things like that. So and gravity potentially as well. So for number 3, we were entering the habitable zone. So I rolled a 35. So this would be a small terrestrial planet. So just to note here, it says a small terrestrial planet is a small rocky world, perhaps with a small metallic core, larger than a mesoplanet, which would be a dwarf planet. So this would be things like Pluto, Ceres, stuff like that. The small terrestrial will be bigger than that and may have a thin or tenuous atmosphere. So this is more along the lines of, like, I guess you could say like Mars. Yeah, I would say that this probably would be like Mars, or maybe a little smaller, or like the moon, or something along those lines. So not habitable, that's for sure. So we're going to go ahead and roll to determine what would be here in orbit 4. And, oops, sorry. And I rolled that we have, we actually have just a regular terrestrial planet. So in other words, this is basically like an Earth-like planet. Now we need to go ahead and roll 4 more times in the outer solar system. So I'll go ahead and do that real quick, and then we'll report on what we got in the end. Welcome back. So basically, in the process of rolling all of this, I rolled that we had a gas giant, an asteroid belt, a brown dwarf. Basically, a brown dwarf is a gigantic gas giant that's not quite big enough to turn into a star. So usually these are between like 75 to 80 Jupiter masses. And then a gas ultra giant, which again, that's basically a super Jupiter. So probably somewhere like along the lines of 10 or 12 times the mass of Jupiter. So huge gas giants out here on the outside. So the next thing we need to do is, there's one more thing we need to do on this page, which is, it says here, determine the primary asteroid composition of this, this asteroid belt, which we'll go ahead and do right now. They want us to roll 1d10, and then we're going to actually add +3 to that roll, since this is on the outer system. And because I rolled a 3 plus a 3, that's a 6. So here we have a primarily stone and rock. So it's not ices, it's not carbon, it's not iron or iron nickel asteroids or heavy metal asteroids. This is like light silicas and things like that. Then it says determine the satellites for each world. So I'm going to go ahead and roll for our glaciated companion, just like I did last time. Let's see. So we do have a minor ring system. And that's it. So this glaciated planet has a minor ring around it. I'm going to go ahead and roll all of the rest of these, and we'll be back in just a second. So, yeah, I just completed rolling our moons. So, again, as we mentioned on our companion star, we had a minor ring, just like a little, basically, dust ring kind of orbiting around our glaciated planet here, our terrestrial but primarily iced over ice age planet. For our reducing planet and superterrestrial, we have 2 little moonlets, which again, these are like essentially captured asteroids or something. For our small terrestrial, we had a small moon. For our terrestrial paradise planet, we had 2 little moonlets, and that's it. For our gas giant, we had 1 major ring accompanied with 4 minor rings, 8 moonlets to 3 small moons, and 2 huge moons, which technically are essentially planets. Of course, our asteroid belt is just an asteroid belt. Our brown dwarf, I didn't roll anything for here. It doesn't actually list anything in the table, and I also kind of feel that if it's gotten to the point where it's a big dwarf, like a brown dwarf planet, it's probably its gravity zone is kind of probably too big. It probably would have pulled any moons inside of itself and stuff like that. And then for our gas ultra giant, we had 7 minor little rings and 7 moonlets. So I'm thinking probably they're like interspersed in between them. 4 small moons, which again, these are like really small, sort of super, super small planets, no atmosphere, 7 medium moons. These would be larger than our moonlets or small moons, but still like not large enough really to have like a significant atmosphere. Probably has a bunch of ice on it, might be somewhat rocky. Then 4 huge moons, which again, these are basically planet-sized. So I would, in theory, I should roll just to see what these 6 moons types, what types of things these 6 moons are, but I'm not going to bother doing that right at the moment. And then we go into actually generating the planet, where basically we take the type of planet that we've got, and then we start working down, size, gravity, atmosphere, all of this stuff, which we will not go ahead and jump into today. Instead, we will go ahead, and then of course here, because again, this is Warhammer 40k, we have Imperium world classifications, where we talk about like what type of planet this is, whether it's an agricultural world, a feudal world, forge world, civilized developing world, so on and so forth. Again, thank you all for joining us again here today on Hastings County for Galaxy 2024, where we're taking a look at Liber Astarte. Again, this is sort of like this was a fan created system created like 14 years ago with the intention of being used with the various Warhammer 40k TTRPGs. So again, I can't put a link in the description down below, but you can definitely find it with Google searches and stuff. You can probably find a copy of it somewhere. I stumbled across this years ago. It's been sitting on my hard drive for ages, so I'm sure it's still out there somewhere. But again, thank you all for joining us. Don't forget to rate your itch purchases and have a good zone.